All right, let's finally introduce the binomial model. So this is just like a description. It's a category for discrete random variables. Remember, discrete means that they're only a finite number of things, whereas continuous random variables, we'll talk about that later, that can be infinitely many things with infinitely many things in between them. Discrete can be finite, infinite too, actually. We're not going to worry about infinite discrete though. But in general, discrete just means, can you count them? And maybe you're counting to infinity, but can you count them? Don't need to split hairs here. So let's look at Bernoulli trials. We talked about Bernoulli trials in the previous video. If we have Bernoulli trials, okay, if we have this experiment that we're repeating multiple times that satisfies those three conditions, if we have an experiment that we're repeating multiple times and we want to count how many successes there are. So in the previous one, it's kind of easy, relatively simple to figure out what is the probability of our first success being something, but it becomes much more complicated. We want to know what's the probability of any number of successes in any organization, any pattern. And that's a binomial random variable. The random variable of exactly one success, exactly two successes in any order for a repeated experiment, that's binomial. Okay, and doing it by hand is possible. It uses something called combinations. You may have heard of those before. They're written kind of like this. But we're not going to do that. We're going to use a computer. We're going to use GeoGebra. So let's talk about some notation. So this means right here that the random variable x is distributed binomially. I think that's right. It sounds weird. Binomially distributed like a binomial, distributed with number of trials n, or n trials. So n free throws in the previous example, with success rate p. So if I write, for example, x is binomially distributed, sometimes we just write b. But that can be a little, I usually see it like that, but if we're looking at Bernoulli, then it's, let's be consistent. If we say x is distributed like a binomial, 10, 0.5, this has to do with a random variable that we're doing 10 times, an experiment we're doing 10 times, and each has a chance of 1/2. So maybe this is flipping a coin 10 times and counting the number of heads. Okay, this is an example here. That would also be a binomial random variable. Or rolling 3 dice and counting how many of them match your chosen number. That would also be a binomial random variable. So let x, again, getting a little off topic, looking on the left, p is the probability of success, q is the probability of failure, so 100% minus p%, or 1 minus p. X is how many successes we're looking for. Okay, so probability that x equals 2 would be the probability that she makes 2 free throws. And the expected value and standard deviation have simple formulas, relatively simple formulas that you can use, or you can use a computer. So this is what you're going to see pretty soon. We're going to use GeoGebra's probability thing. Okay, the probability in GeoGebra Classic, and I'll provide a link for all of you. That's the worst G I've ever written in my life. And that's probably a lie. I've probably written worse G's, which is kind of sad. Let's go back to the example with our basketball player. She's still making 82% of her baskets. We're going to still assume that each shot's independence and that this probability is not changing. And now she's going to shoot 10 free throws. She's doing this thing 10 times. The number of trials we're going to call n. Let's write that down. As soon as, okay, 82% of her baskets, that's something. She's shooting 10 free throws, that's something. N trials. What's the chance of a success? 0.82 is our P, just like before. So what's the probability that she makes exactly 5? We need to write this as a random variable. Okay? So let X be the number of successful free throws, out of 10 attempted. This is a binomial random variable because she's shooting the free throws. It's a Bernoulli trial. And we're calculating what's the chance that she does it exactly 5. It doesn't matter which 5 of those 10 are. And in fact, if you wanted to write every possible combination like we did, if you wanted to go here and do every combination for her to make 5 free throws out of 10 attempts, you'd have to write down, let me calculate this out. You'd have to write down 252 different combinations. Okay, so we can't just do what we did here. We'd have to write 252. Well, we wouldn't have to write it. We'd actually just multiply it by 252. So we could do it by hand, but it'd be hard to visualize. But this is a binomial random variable. And so what we're going to do is we're going to say X is distributed like a binomial, and it has number of trials n with probability p. This is how we write this. And what we're curious about is what is the probability that, not like that. What is the probability the number of successful free throws out of 10 is exactly 5? So here's what we're going to do. We are going to go into GeoGebra, GeoGebra Classic. And I have a direct link, but if you ever forget, if you ever don't have the direct link, click on the boxes here, go to GeoGebra Classic, and then go over here, and then go over here. This also is a way to get to the spreadsheet. We're using the probability calculator. But again, I will give you the direct link. We don't need this. We're just going to pull it over. So now we don't have a normal random variable, so it's not going to look like this. So go down here, say, I don't want normal. Who wants normal? And this is going to give you a drop-down menu that you actually can't see right now for some reason. It's going to give you a drop-down menu, and one of them is going to be binomial. So click on binomial. Tell it, how many trials do you have? What's your n? You have 10 trials. She's shooting 10 free throws. And what is the chance that she makes a given free throw? P is 82%. And now this automatically calculates and shows you what are all the probabilities for all of these free throws. So what's the probability that she makes 0? Well, if it's 82% chance of a success, the probability she doesn't make any of them is really, really low, right? This is almost 0. And in fact, to 4 decimal places, it is 0. And we could pick 5, because that's what we care about. What's the probability that she makes 5 free throws? It's pretty unlikely, 1.8%. What's the probability that she makes exactly 7? That's a bigger number. What's the probability that she makes at least 7? You can highlight a bunch of them. And it tells you, it adds them all up for you before, and you can see visually probability that she makes at least 7 free throws is all of these combined. So pretty likely, right? This is most of the graph in terms of area. And it has to correlate with probability. Some really cool connections here. Okay, but I'm getting ahead of myself. We only care about this. What's the probability that she makes exactly 5? It's pretty small. 0.0177. So let's write that down as our answer. 0.0177, or you could say about 1.77%. What's the probability that she makes at least 9 or 10? And there's two ways of writing this. You could say 9 or 10, or you could say, what's the probability she makes at least 9? Okay. So on GeoGebra, you have two options. You can say click 9 or 10, like so. Or what you could do is you could go down here and insert it manually. At least 9. That uses this one, right? It's like interval notation with a bracket. At least 9 is this. And you can just manually type in 9. And so it says 9 is less than x, less than or equal to x. That's the same thing as x is bigger than or equal to 9, right? If I'm taller than you, you are shorter than me. That's how this inequality works. The order matters. But either way, at least 9 is 43.92%. All right, so this is a decent chance that she makes at least 9 free throws. She's pretty good. I don't know much about basketball. That seems pretty good. I don't know. Actually, I really don't know. You tell me. You tell me, all right? You let me know if this is good or not. It looks good to me, but I suck at basketball. What's the probability that she makes at most 2? So what's the probability that the number of free throws she makes is less than or equal to 2? Again, at most means less than or equal to 2. So you type that in. Less than or equal to 2. If you wanted to, you could just highlight 0, 1, or 2. Or, hold on, my GeoGebra is a little buggy sometimes. I'm going to try refreshing it and then going back to it. Maybe it was my computer. And then again, we just care about the probability. Go back to binomial. There are 10 trials. Success is 0.82. What's the probability of 0, 1, or 2? About 0%. Or what you could do, let me zoom out a little bit. You could look at all the numbers that are less than or equal to 2 and type it in like this. Either way, you should see that these correct ones are highlighted, and the sum, it adds up to about 0%. There is a chance, but it's so small that since the computer is only rounding to 4 decimal places, it says about 0%. But we're missing a little precision, but that's what's going on here. So it's not technically 0. We're going to say it's approximately 0. All right. So it's 0 to 4 decimal places. Very unlikely that she makes 0, 1, or 2 free throws. She's doing pretty good. What's the probability that she makes at least 7? Probability of at least 7. Go over here. 2 ways of doing it. I'm going to click right-sided. At least 7. It highlights these up here. I don't want this. Go away. Why are you doing this? One of the downsides to GeoGebra, it has a lot of power and it is free, which is good. But, oh, that was the wrong call. All right. But you can kind of see what's going on right here. Okay. And so just type those in and see what you get. So what I'd recommend for these last couple of problems, pause the video, type things in, and see whether you get the same answer that I do. Okay, so at least 7 free throws is going to be 91.17%. What's the probability she makes between 6 and 8? The probability that x is between 6 and 8 is written like this. Right? X is bigger than 6 or equal and smaller than 8. And again, there's two ways of doing this. You can click on it manually, or you can use this between button. Between 6, not 76, between 6 and 8 is this amount. How much is this amount? You could visually estimate it to be about half, or you could look at the answer and say 53.95%. So yeah, she makes between 6 and 8 free throws about half the time. What's the expected number? What's the standard deviation? Well, you could use these formulas. Expected value, standard deviation. Expected value is NP. Standard deviation is NPQ in a square root. Or maybe you don't like formulas. Maybe you want to say, Jason, it's right here. Right here. Computer already did the work. We can use that too. So on average, well, let's just write it down. The expected value of how many free throws she makes was 8.2. The standard deviation was about 1.2149. So you could say she makes about 8 baskets, plus or minus 1 basket on average. Okay, and for units, don't ever forget your units. Successful free throws. Out of 10. And you can just copy this down because the units are the same. So on average, 8 about, plus or minus 1. If you look at this, yeah, on average 8 plus or minus 1, it says most of them are in this interval, which is true. It has about 77% of them. Just a way to conceptualize standard deviation. Okay, and that's basically everything. I'll have another video with some more examples, but let me know if you have any questions.